In the last lecture, we were talking about simple pendulum, an example of oscillation that is simple pendulum. So, if you consider a simple pendulum, in the last lecture, I had already explained what is meant by a simple pendulum, what is ideal simple pendulum, what is practical simple pendulum, and what is length of a pendulum, all that. So, suppose this is a simple pendulum which is in the equilibrium state. Okay. In this state, the forces acting, weight acts vertically downwards from the center of gravity. Weight is acting vertically downwards from the center of gravity. And another force is tension in the string. And since it is an equilibrium condition, therefore T is equal to mg. Now, if you displace the bob, this bob, slightly towards one side, एका साइडला त्याला ओढलं आणि सोडून दिलं, what will happen? It will perform simple harmonic motion. So, if that bob is displaced slightly, that is important. If the bob is displaced slightly, खूप जास्त असं ओढायचं नाही त्याला, कारण खूप जास्त ओढलं तर ते मोशन असं होईल, which will not be linear simple harmonic motion. A linear SHM असणार नाही. So, if you displace the bob slightly towards one side and leave it, then it will perform linear simple harmonic motion, linear SHM. So, suppose if you pull the bob towards one side, मी खूप जास्त ओढून दाखवलं, एवढं जास्त ओढायचं नाही, यू हॅव टू डिस्प्लेस इट स्लाइटली. हे जास्त काय दाखवलं, का दाखवलं, तुम्हाला क्लिअर अंदाज यावा म्हणून. सो सपोज if you displace it through an angle theta. Okay. Now in this position, what are the forces acting on the bob? एक तर असणार त्याचा weight mg, which will act vertically downwards, and another one will be tension in the string, that is T. So two forces are acting, weight of the bob vertically downwards and tension in the string along the string. Now, are they equal and opposite? Of course not, because their directions are different, so they are not opposite. You can resolve this mg into two components. तुम्ही कोणत्याही व्हेक्टरचे, weight is a force, force is a vector, कोणत्याही व्हेक्टरचे तुम्ही कॉम्पोनेंट्स देऊ शकता. सो इफ यू टेक सपोज component, this angle is theta, so this angle is also theta. So this component will be what? mg cos theta. आणि mg cos theta ला perpendicular असणार mg sin theta. So we resolved mg into two components, mg cos theta and mg sin theta. Means now there are three forces, T, mg sin theta and mg cos theta. If you look at this figure, T and mg cos theta, they will be equal and opposite, equilibrium. So tension in the string T is equal to mg cos theta. Agreed? But this mg sin theta is unbalanced force. त्याला balance करणारा कोणताच force तिथं नाही आहे. So mg sin theta is unbalanced force. So when you leave this bob, what will happen? Due to this mg sin theta, the bob will accelerate towards the mean position. Due to mg sin theta, the bob will accelerate toward the mean position. When it reaches here, it will not stop. Why? Because it possesses kinetic energy. So it will move further. As it moves further, theta goes on increasing, and mg sin theta now will be in this direction. It will also go on increasing. So at one stage, due to that mg sine theta, the bob will stop, and then due to that mg sine theta, it will travel back, not stop here, move further. In this way, it will perform oscillatory motion. So this mg sine theta is the force due to which the bob moves towards the mean position. इथे किंवा इथे दोन्हीकडे mg sin theta मुळे तो बॉब काय होतो, मीन पोझिशन कडे परत येतो. मीन्स दिस mg sin theta is what? Restoring force. That force is trying to restore the original position. So you can say that F is equal to mg sin theta. So the restoring force F is mg sin theta. Now we said that the bob is to be displaced slightly. खूप जास्त ओढायचं नाहीये. The bob is to be displaced slightly means that theta is very small. And if theta is very small, in that case, sine theta is approximately equal to theta. You know this, we have done that before. So when theta is very small, sine theta is equal to theta. Small म्हणजे किती? Up to 6 degree. Up to 6 degree, you can take sine theta equal to theta without any error. But above 6 degree, up to 10 degree, there will be an error. It will not be approximately equal to theta, but you can take it up to 10 degree, okay, with slight error up to 4 decimals. So as theta is very small, sine theta is equal to theta. So F will be equal to mg theta. In place of sine theta, we can take theta. And since this theta and restoring force are in opposite directions, we can say that F is equal to minus mg theta. So F is the restoring force, theta is the angular displacement, m is mass of the bob, and negative sign indicates that the restoring force is in the opposite direction of theta. Theta is increasing in this direction, restoring force is in the opposite direction. So F is equal to minus mg theta. Now since theta is very small, this arc will be a straight line. Small arc, small part of an arc is a segment. So as theta is very small, this arc is a straight line, means it is nothing but displacement from the mean position, and we can say that theta is equal to arc upon radius, that is x by L. So theta can be written as x by L, whereas x is displacement from the mean position and L is length of the simple pendulum. And remember that whatever we are talking about for very small displacement. इथूनच पहा, आपण इथूनच काय करतोय, sin theta nearly equal to theta. Why? Theta is very small. Theta is equal to x by L. Why? Theta is very small. Then this arc will be x, straight line. So for a small displacement, theta is equal to x by L. Putting this value of theta here, we can say that F is equal to minus mg. In place of theta, it is x by L. So F is equal to minus mg x by L. Agreed? This m is mass of the bob, which is a constant. G is acceleration due to gravity, which is constant at the given place. L is length of the pendulum, that is also constant, means F is proportional to x. So the restoring force is proportional to x, means the force is directly proportional to displacement from the mean position, and the direction of force is opposite to displacement from the mean position, means the motion is simple harmonic motion. So motion of the simple pendulum is simple harmonic motion because both the conditions are satisfied here. Now the time taken by the pendulum to complete one oscillation will be called periodic time of the pendulum. Obviously, what will be that periodic time equal to? In a simple harmonic motion, T is 2 pi under root m by k, that we have seen before. T is equal to 2 pi under root m by k. Or you can say T is equal to 2 pi upon under root k by m. चलेगा, दौड़ेगा. T is equal to 2 pi under root upon under root k by m. That is equal to 2 pi upon under root. What is the meaning of k? Force constant, force per unit displacement. So in place of this k, we can write F by x, force per unit displacement. और नीचे क्या है? m. ठीक? This F by m, force upon mass, क्या होता है? Acceleration. Acceleration is force upon mass. So this T will be equal to 2 pi upon under root. F by m means acceleration upon x. So T is equal to 2 pi upon acceleration upon x. Or you can say T is 2 pi upon under root acceleration per unit displacement. T is equal to 2 pi upon under root acceleration per unit displacement. This is general formula for periodic time of SHM, not only for simple pendulum. Anywhere you can apply it. Periodic time is 2 pi upon under root acceleration per unit displacement. Correct? Now let us come back to simple pendulum. We have to find the periodic time of the simple pendulum. So, for a simple pendulum, T is equal to 2 pi upon under root acceleration per unit displacement. Correct? We have to find the periodic time of the simple pendulum. Now, we have derived this formula. What is that? F is equal to minus mgx by L. Right? So what will be acceleration? Acceleration will be minus mgx by L. मतलब कि force upon mass. Acceleration is force upon mass. So this mm gets cancelled. Therefore, acceleration is equal to minus g x by L. Or if you neglect the direction, then acceleration per unit displacement will be equal to g by L. So acceleration per unit displacement in simple pendulum is g by L. This value we can put here. So T will be equal to 2 pi upon under root acceleration per unit displacement, that is g by L. So T is equal to 2 pi upon under root g by L, or you can say it is equal to 2 pi under root L by g. इसको अगर ऊपर ले जाओ, g by L will become L by g. So period of a simple pendulum is given by T is equal to 2 pi under root L by g. That is the formula for periodic time of a simple pendulum. T is equal to 2 pi under root L by g, whereas T is the periodic time, L is length of the pendulum, and g is acceleration due to gravity at that place. देख लो एक बार. So T is equal to 2 pi under root L by g. That is the formula for period of a simple pendulum. Means periodic time of a simple pendulum is directly proportional to square root of length of the pendulum. periodic time is inversely proportional to square root of acceleration due to gravity at that place. याचा अर्थ काय? T is directly proportional to root L. म्हणजे पेंडुलमची लेंथ जर कमी जास्त केली तर पिरियडिक टाइम काय होईल? चेंज होईल. लेंथ वाढवली तर पिरियड वाढणार, लेंथ कमी केली तर पिरियड कमी होणार. अँड T इज इन्व्हर्सली प्रोपोर्शनल टू रूट जी. म्हणजे जर जागा बदलली, इफ द प्लेस इज चेंज्ड, acceleration due to gravity will change. We have seen that in gravitation या चॅप्टर मध्ये आपण याचा डिटेल मध्ये अभ्यास केलेला आहे. The acceleration due to gravity is different at different places. So if the place is changed, if g changes, then there will be change in t. g वाढला तर t कमी होईल, g कमी झाला तर t वाढेल. g सर्वात कमी कुठे असतो? इक्वेटरवर. Am I right? The acceleration due to gravity is minimum at the equator. So periodic time will be maximum at the equator. And as you go from equator to poles, acceleration due to gravity goes on increasing. So periodic time will go on decreasing because T is inversely proportional to square root of G. म्हणजे एकच simple pendulum, the same simple pendulum, if it is taken to different places on earth, its periodic time will be different depending upon the acceleration due to gravity at that place. And as you can see from this formula, there is no mention of mass. Means period of a pendulum doesn't depend upon mass of the bob. बॉबच्या मासवर डिपेंड नाहीये. कितीही मास असेल त्याने फरक पडणार नाही. मोरओव्हर देर इज नो मेन्शन ऑफ एम्प्लिट्यूड. एम्प्लिट्यूड वर पण डिपेंड नाहीये. एकतर नक्की आहे पण की स्मॉल डिस्प्लेसमेंट पाहिजे, मग ती स्मॉल मध्ये थोडी कमी थोडी जास्त फरक पडणार नाही, बिकॉज देर इज नो मेन्शन ऑफ एम्प्लिट्यूड हियर. सो दॅट इज द पिरियडिक टाइम ऑफ अ सिंपल पेंडुलम. And a simple pendulum whose periodic time is 2 seconds. A simple pendulum whose periodic time is 2 seconds is called seconds pendulum. Seconds pendulum means a pendulum having periodic time equal to 2 seconds. आपल्या घड्याळाचा जो पेंडुलम असतो that is seconds pendulum. त्याचा periodic time असतो 2 seconds. टिक टिक 2 सेकंद लागतात एक ऑसिलेशन पूर्ण करण्यासाठी. त्याला 2 सेकंद लागतात. टिक टिक म्हणजे हाफ ऑसिलेशन मध्ये त्याच्या 1 सेकंद होतो. सो दॅट इज सिंपल पेंड्युलम.